Hi, my name is Rob Skilton. I'm Head of Research at RACE, which is the UK Atomic Energy Authority's lab for robotics in extreme environments. Our background is in maintenance for nuclear fusion experimental devices. And historically, we've operated robotic systems that are there to reconfigure and maintain the JET experimental device based in Culham in the UK over the last several decades. Fusion is a really exciting opportunity because it potentially could be a highly clean, low carbon energy supply that will produce vast quantities of energy for humanity in the future. But it has some really difficult challenges associated with it. This is partly because of the radiation that's produced as part of the fusion reaction, in which many high energy neutrons are produced which interact with the fusion device itself, the vessel and components, and cause damage, which means that those components need to be replaced on a regular basis, which is very different to conventional fission reactors. That radiation also means that people can't go in to do those things themselves and to change those components. And it also means that we can't use conventional off-the-shelf robotics and electronic devices. What that means is that typically highly bespoke systems are required, and due to the nature of fusion, they are required to operate in these conditions for many decades through the life of an experimental device or a power plant. Through that time, we've noticed, and through operation of JET over long periods of time, the requirements of the plant change. The requirements of the plant change, but also the available technologies change, with new technologies becoming available, but old technologies becoming obsolete and unavailable. And hence, the systems need to flexibly adapt to these changing requirements. That is a problem that is not just true for fusion. In fact, we're looking at a wide range of long-lived facilities where robotic maintenance and robotic intervention is required over decades-long operations for maintenance and for cleanup and recovery. These changing operational requirements can be for changing experimental needs in the case of scientific devices and facilities such as the fusion facilities that I've described. It could be that we have a changing understanding of the problem that we're trying to solve. So in the case of disaster recovery scenarios, for example, where we have limited knowledge of what the situation of the environment is, we can send robots in, but then as we discover that the situation is different to what we first anticipated, the needs change and we need to update the robots and devices to be able to accommodate that. There may also be changing priorities, which may be as a result of changing political scenarios, it may be as a result of changing funding streams, or many other reasons. And we can also see a situation where new technologies become available and old technologies become unavailable, meaning that we need to replace systems and devices and upgrade and expand the system and its capabilities as we go. In our experience, this often leads to changing architecture of the plant and gets progressively more difficult over time as the architecture degrades with these incremental changes over long periods of time. These challenges also exist in other areas. So we've talked about fusion, and we have Emilio from F4E who will be talking about some of the challenges for ITER. Nuclear decommissioning is one of the key areas where we see this type of challenge, and we have speakers from representing challenges at Sellafield in the UK, but also our partners from TEPCO in Japan, who are working together with us on the Long Ops program, which is around decommissioning Fukushima Daiichi. The problem exists in large-scale experimental devices such as the Large Hadron Collider and the European Spallation Source. And we have Mario from CERN, who will be talking about some of these challenges. Outside Earth, obviously space is also a very interesting challenge for robotics. And we see a lot of the same challenges in terms of extreme environments, changing requirements, but also facilities which need to remain in place and do their job for decades at a time, but potentially with changing requirements. And examples of this are service, maintenance, and decommissioning of satellites on orbit. So the challenge we have is to facilitate long-lived robotic facilities for doing maintenance and decommissioning work over decades of operations in the face of changing environments, changing environmental conditions, changing understandings of the problem, and changing operational needs. We need to address this challenge and allow robotics to fulfill this need whilst reducing the full through life cycle cost. And that means promoting the ease of reconfiguration of robotic devices, the ease of extension and reuse of those devices. In the robotics industry, we see several other initiatives around the world that have done similar things and have tried to address similar problems. We can talk about systems like ROS and ROS2, which have provided software frameworks to allow the ease of development of robotic modules and systems. We can look at things like OPC-UA and industrial communications and data representation standards, which allow some degree of interoperability. We can also look at similar scenarios that have occurred in other areas, such as in defense. And one example of this is in the UK, an initiative called the Generic Vehicle Architecture, which has been put in place in order to address the need for long-lived land platforms and vehicles that have to operate over decades of use in changing operational requirements and changing environments. And there are many others, and you'll hear about some of these through some of our talks today and from some of our other speakers. In the UK, we have a lot of work going on in this area, and that's why we from the UK Atomic Energy Authority have organised this, and why we have several speakers from the UK. We've been doing a lot of work in this area for the last 10 years and plan to significantly ramp up and expand our activities in this area through activities and collaborations such as the Robotics and AI in Nuclear Hub, RAIN, as well as the Robotics and AI Collaboration, RACO, partnerships, who will be looking at standards for robotics, interoperability, and reduction of through-life cost of robotics in challenging scenarios. But it's our ambition to engage more widely and share this challenge and raise awareness of some of the things we're trying to do and some of the problems which need solving. And that's one of the reasons we're here today. We can develop technology that allows us to do these things, allows us to have interoperable, long-lived robotics that operate in nuclear and other facilities over decades of use. But the technology isn't entirely the problem, and there are still many challenges which need to be solved before this is really adopted in industry and widely used. Some of those challenges include the verifiability of these systems and the safety and security. There are clearly trade-offs to be made between the flexibility and adaptability of a system and the ability to safely certify and assure these systems. So we're interested in talking to experts on security, cybersecurity, and safety and assurance about some of these challenges. One of the big challenges related to those is trust. And it's not just a case of assurance that we have to solve, but actually culture and convincing people that these systems are safe and that they can be safely operated and that they will do what is required. And that relates to reliability and through engagement and long-term demonstration with those end users. Another issue is training. And actually, if we create amazing systems which solve all of these problems, but we can't teach people how to use them, how to develop systems with them, and how to operate them, it's not going to be useful. So training is going to be a key part of any initiative to solve some of these problems. And you'll hear some of the activities that are being talked about today and how they relate to ease of training and making that as easy as possible. And we need to enable widespread uptake and community. ROS is great because it has a community behind it, and there is very widespread adoption of it. How do we make a system which does what we need for a niche industry like nuclear or like space widely adopted and usable in a wide range of industry, creating a diverse supply chain and opportunities to widely develop and mutually support development of these activities? So just to summarize, there is an opportunity here for robotics, software and standards to have enormous value in allowing robotics and AI systems to be used to solve some of the world's challenges in nuclear, in disaster recovery, and in other industries such as space. But there are many other problems to overcome. That's why we're here today. And we want this to be an open discussion. We want to talk with you and hopefully understand some of the challenges which are taking place in these industries, some of the reasons that robotics are not able to be adopted in some of the world's biggest problems, and also talk about some of the emerging technologies and fields of research that can potentially solve some of these great challenges. Thank you very much for joining us for today's session. I hope this will be a really interesting and it is a very important topic. And I hope that this will be the start of a longer conversation and collaboration. Thank you very much.